Hello everyone, welcome. In this video, let us solve this equation. So we have square root of 3 plus square root of x is equal to 3 minus x. Okay, to solve this, looking at this expression right here, okay, this expression has radical sign and the value is greater than or equal to 0. Okay, and also looking at 3 minus x right here, this expression should also be greater than or equal to 0. Now from here, we have it that 3 minus x should be greater than or equal to 0. To then solve for x, we have it that 3 is greater than or equal to x, such that, so therefore x is then less than or equal to 3. With this, looking at this x right here in this square root, okay, the value of x right here, x should be greater than or equal to 0, right? Now, such that we have it that x is less than or equal to 3 and is greater than or equal to 0. So this is a predefined domain, okay, for this expression. To then solve this, looking at this side of the equation, okay, let us square it and then call it a squared, such that a squared is equal to, in brackets, square root of 3 plus square root of x all squared. Now, square will cancel square root. What you have is a squared is equal to 3 plus root x. And also, let us call this 3 minus x as a. So, a is then equal to 3 minus x. Now, at this junction, subtract the both equation. So, what you have is a square minus a is a square minus a is equal to 3 minus 3 is 0. Then you have plus root x. So, root x, then minus x. So with this, a squared minus a is equal to root x, then minus times minus is plus x. With this, let us then rearrange this so that we have it as a squared then plus x crossed over minus x is equal to root x, and then minus a move here, it becomes plus a. Now this x right here can be expressed in the form of x is equal to, in brackets, root x all squared. It still means the same thing. So in place of x, we'll put in root x, right, all squared. Good. So we have it as a squared then minus into brackets root x all squared is equal to, then you have root x then plus a. Okay, at this junction, what you have is difference of 2 squared. Now, if you have a squared minus b squared is equal to, in bracket, a plus b times a minus b. So, applying this principle to this, what we have is a and b is root x. So, we have it as, in bracket, a plus root x, okay, times a minus root x is all equal to this root x plus a, such that we have it as, in brackets, a plus root x then times a minus root x. Rearrange this, it becomes is equal to a plus root x. Move this to this side of the equation. We have it as, in bracket, a plus root x times a minus root x, then minus, in bracket, a plus root x is then equal to, here becomes 0. Now, factorizing out a plus root x, we have it as a plus root x, then we have a minus root x. If you bring out this from here, we are left with minus 1 is then equal to 0. So with this, at this junction, a plus root x is equal to 0, and also a minus root x minus 1 is equal to 0. So a plus root x is equal to 0, or this a minus root x minus 1 is equal to 0. Now, a is then equal to minus root x, or from here, a is then equal to this crosses over, we have it as root x plus 1, right? So, at this junction, recall that at the beginning, the value of a is greater than or equal to 0. Now, looking at these two values of a, right here, a is negative root x. So, a is minus is less than 0. So, this value of a can't work. So, we have it as a is equal to root x plus 1. So, definitely, we are going to go with this value of a. And also, in the beginning, we said that a squared is equal to this guy right here, root 3 plus root x all squared. Is it not so? Good. The value of a that we're working with is a is equal to root x plus 1. Now, to then convert it to a square, we all square both sides. So therefore, equating this to this, it becomes root 3 plus root x all squared, right, is equal to root x plus 1 all squared. With this, looking at this right here, we have it that if you have a plus b all squared is equal to a squared plus 2ab plus b squared. Now applying this principle to this, we're going to have square will cancel square root. We have 3 plus root x is then equal to, then a here stands for root x, while b stands for 1. So a squared is then becoming root x squared, then plus 2 times a is root x times b is 1, then plus b is 1, so 1 squared. So with this, we have 3 plus root x is equal to square cancel square root, we have x, then plus 2 times root x times 1 is 2 root x, then plus 1 squared is 1. Okay, at this junction, move x and 1 to this side of the equation. So we're going to have 3 then minus x, then minus 1 is equal to 2 root x, then this minus root x. Okay, with this, we have it as 3 minus 1 is 2, then minus x is equal to 2 root x minus root x is equal to root x. Okay, then square this. Okay, also square this side also, such that square cancel square root. We have 2 minus x all squared is equal to x, right? At this junction, if you have a minus b all squared is equal to a squared, then minus 2ab plus b squared. So applying this principle to this, we have it as a is 2 and b is x. So a squared is 2 squared, then minus 2 times a is 2, 2 times b is x, then plus b is x, so x squared is then equal to x, so x. Now 2 squared is 4, minus 2 times 2 times x is 4x, then plus x squared is equal to x. At this junction, we'll bring x to this side of the equation such that this x squared stand here, x squared, then minus 4x, then minus x, then this plus 4 is then equal to 0. Okay, then factorizing out x from here, x comes out, you have x minus 4. Also factorizing out minus 1 from here, you have minus 1 in bracket, x, then minus 4 is then equal to 0. With this, we have two common factor, x minus 4, x minus 4, pick one. So in bracket, x minus 4, then we have x minus 1. So x minus 1 is all equal to 0. At this junction, x minus 4 is equal to 0, or x minus 1 is equal to 0. So from here, x is then equal to 4, or x is then equal to 1. Good. Now we've gotten two values of x. x1 is equal to 4, or x2 is equal to 1. So with this, we have two solutions of x. Let us then verify which of these value of x, okay, is the solution. So verify. Now to verify this, we are going to work with the defined domain, which is x is greater than or equal to 0 and is less than or equal to 3. For x1, right, now the value of x1 is 4. So 4 is greater than or equal to 0, but 4 is not less than or equal to 3. It is greater than 3. So the value of x can't work. Now working with the value of x2, okay, x2 is 1. Now 1 is greater than or equal to 0, but then also it is also less than or equal to 3. So this is the actual solution for the value of x. I hope you enjoyed the video. Please don't forget to like the video, ask your question in the comment section, and please don't forget to subscribe. Subscribe now. Thank you very much. See you in the next video.